With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
A shell fired along a parabolic path explodes into two fragments of equal mass at the top of the trajectory. One of the fragments returns to the point of firing having retraced its original path. If v is the velocity of projectile at highest point, then basically, let's say this was a projectile going through a parabolic path, and at the top it exploded. Now let's say it exploded into two masses, one with mass m1, another one with mass m2. Now this mass m1 retraced the parabolic path according to the question. And the velocity v was the velocity of the projectile at the highest point. So at the highest point in a projectile motion, the only velocity that is available is the horizontal velocity. So that means the horizontal component of the velocity of the projectile was v. Now if I apply the principle of conservation of momentum along the x-axis at this top, I get m1 plus m2 into v. m1 plus m2 will be the mass of the original projectile. This should be equal to m1, let's say v1, plus m2 v2. Now since this m1 mass is able to trace its trajectory back, that means that this m1 is going back with the same horizontal component, because the vertical component is going to be the same, because the vertical component is being determined by the acceleration due to gravity, and that is not changing even after the explosion. So that means this m1 mass, which is able to retrace its trajectory, will have the same horizontal component v in the negative direction. So I can write m1 into minus v plus m2 v2 is equal to m1 plus m2 into v. That means m1v plus m2v is equal to minus m1v plus m2v2, which means m2v2 is equal to 2m1v plus m2v, which means v2 is equal to 2m1v plus m2v upon m2. And in the question they say that the two fragments have equal masses. That means m1 is equal to m2. So that means v2 is equal to 2mv plus mv upon m, which means v2 is equal to 3 times of v. So that means the velocity that the other fragment obtains is 3v along positive x-axis, since the velocity that we calculated is positive. Now after the explosion, the fragments reach the separation 2r between them, where r is the range of the projectile. So since this m1 retraced its trajectory, that means the distance that it has traveled will be r by 2, because the trajectory of the projectile was symmetric. So this will become r by 2. For m2, however, we know that the horizontal range is given by time of flight into the horizontal velocity, which in this case will be 3v. So r2, that is the distance from the point at which the particle exploded to the point at which the mass m2 falls. This is r2. So r2 will be equal to t into 3v, which is 3vt, where t is the total time of flight divided by 2 for this projectile motion. Because as I said, the vertical component is not going to change, only the horizontal components are changing, because along the vertical still only the acceleration due to gravity is acting. So the vertical components are not changing, and since the vertical component is not changing, that means the time of flight is also not changing. And we know that the original range of the projectile would have been 2t into its horizontal component, which is v. So 2vt. So r is equal to 2vt, r2 is equal to 3vt, and r1, as we calculated earlier, will be r by 2, which is equal to vt. So that means r1 plus r2 is equal to 3vt plus vt is equal to 4 times of vt, which is equal to 2 times of r. So the distance between the two particles once they fall will be equal to 2 times the range, which means option number C is a correct option. Now option D, after explosion both fragments hit the ground simultaneously at t is equal to r by 2v. So as I said, both the particles will land after the same time of flight, capital T, and therefore after the explosion they will land at the same time, that is capital T by 2, which is small t. And small t from this equation, where r by from this equation, or rather from this equation, where capital R is equal to 2vt, which means small t is equal to r by 2v. And as I said, this small t is the time after the explosion, after which both the fragments land simultaneously on the ground. So small t is equal to r by 2v, which means option number D is also correct.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.